Okay, I just want to do a quick review of 2.4 and 2.5, so I won't be here tomorrow, and that way hopefully you guys will be able to get 2.5 done. 2.4 is really your sine, cosine transformations, and 2.5 is your tangent, cotangent, secant, cosecant transformations. But the rules are all the same. Who remembers the general form of the quadratic? Hopefully all of you. Okay. A stood for the stretch. HK was your vertex, but really what it meant was how much it shifted left or right, that's your H, and how much it shifted up or down, that's your K. Okay, so those same rules that we used all during Algebra 2 apply to sine, cosine, all those graphs. There's one caveat that's a little different. This would be a shift of H units in the right or in the to the right, and a shift of K units up. This period then of this graph is 2 pi, because the coefficient of x is 1. So you don't have to change this coefficient if the period is 2 pi. To find what that coefficient is, you take 2 pi over that coefficient, that's your period. And so if the period's 2 pi, the coefficient's just 1. Okay. Where it gets a little tricky is when your period's not 2 pi. So if you have a graph of sine, and let me just start it, I don't know, something like that. Let's say that this is pi now. It goes through one full rotation in pi units. Okay. To find this coefficient, I'm going to take 2 pi over pi, and now that number has to be 2. Okay, so really the bigger the number in front of x, the more condensed, the more times, which is the frequency, how many times it does it in 2 pi, it's going to do 2 rotations in 2 pi now instead of 1, which tells you your frequency, how many times it goes through a cycle in 2 pi. Okay, so that's why the frequency is 2, but the period is pi. Okay, now when you look at tangent, cotangent, you're going to take pi divided by whatever that coefficient is, or pi divided by your period, because the period of tangent and cotangent is pi and not 2 pi. Secant and cosecant, though, will go back to 2 pi. Okay, and my hints with graphing tangent, cotangent, secant, and cosecant, start with your asymptotes, because we know where the asymptotes are if it's got a regular period, if it's doing it in pi or it's doing it in 2 pi. So take your asymptotes and figure out where those need to be in the new period. So if instead of 2 pi it's pi, wherever all your asymptotes were, you're going to divide those by 2 to add in those additional asymptotes. Does that make sense? Okay, and so you're going to need to be able to, on a quiz with me, I'm going to, more than likely your problems with me are going to be, on a quiz, will be, I'll give you an equation, and you will have to graph it. Okay, there's a couple questions on WebWork where they give you the graph, and you have to identify the equation. I will probably test you more on being able to take an equation and actually physically graph it. So do you want to go through a sample of graphing an equation? Okay. So let me, do I have any of those books? No. Let's just do one from the textbook. find one that's got lots of stuff going on. Well, I'll just create one. Fun, huh? So what I do with these is I try and just stay organized with if I'm using x and y. So x, if I'm doing sine, and now my screen's not going to let me write. Come on, screen. If I'm going to just do, God, come on. When x is, if I just did y equals sine x, when x is 0, sine is 0, right? And I have, this is one full period, right? This is 1, back to 0, -1, back to 0. Okay, so when I look at the new period, if I were just going to do sine of this, what's the new period going to be? Well, I take 2 pi divided by that, right? And actually, let's take pi out of it. I don't want to, that's going to be too confusing right now. So 2 pi over 2/3 is 6 pi over 2, or 3 pi, right? It was 2 pi, and now my period is 3 pi, okay? So I have an interval here, 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 here. So there's 4 different intervals to get from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. So I'm going to divide this by 4. My first one is still going to be 0. My second one's going to be 3 pi over 4. Okay, because I'm just basically, I want to go from 0 to 3 pi in 4 intervals. Does that make sense? From 3 pi over 4, if I add 3 pi over 4 to that, because I'm doing it by 3 pi over 4, I get 6 pi over 8, no, over 4, sorry, which is, if I add 3 pi over 4 to this, 6 pi over 4, which is 3 pi over 2, right? So this is back to 0. No, I'm just doing this side, sorry. 3 pi over 2. God. And then I'm going to add 3 pi over 4 to that. So I get 10 pi over 4, which is, no, 3 pi over 4 is 9 pi over 4, right? And then when I add 3 pi over 4 to this, I get 3 pi, which is where I should end up. Because now I've just gone from 0 to 3 pi, and these are my intervals. Make sense so far? I want to get it into the, it's going to be 2/3 times x minus something is going to equal 2/3 x minus 2. Because 2/3, if I've got a phase shift, 2/3 is outside that parenthesis. So I've got to figure out what this is, because the shift is not 2, because the 2/3 is still in there. So 2/3, the way, if it's hard for you to imagine what it is, I just do this. 2/3 of what equals negative 2? So this should be negative 1/3. And I can check it. Is that right? Negative 3, not negative 1/3. Is negative 3 times 2/3 negative 2? Yes. So this equation I could rewrite okay. So this then is going to shift. If I get all these points for sine of 2/3 x, and then I take each one of those points and I shift it 3 radians, in this case, to the right, I'll have this piece fixed, right? So this is going to be plus 3, plus 3, plus 3, plus 3, plus 3.
So if you're adding 3, that means it goes to the left, right? If you're adding, I thought it meant it goes to the left.
Yeah, but what I'm saying is if I'm plotting these points, these x, y coordinates, my x coordinate, because this is minus 3, shifts right 3 units. And then my y, it's stretched by a factor of 2, flipped over the x-axis, and then shifted up 3 units. Okay, so if I were to look to graph this, I would start at 0. If it would be, this is now shifted up 3, stretched by a factor of negative 2, right? So the 0 is now, instead of 0, I'm multiplying that by negative 2, which is still 0, and shifting it up 3. So it's 0, 3. Multiplying this one by negative 2, which is negative 2, shifting it up 3, is now at 1. Multiplying, this is pi, 0, this is at 3, this should be at, then I multiply, this is at negative 1 times 2 is 2, up 3 is at 5. And then I'm back to 3. So my points are 3, and then I go to, it's not 0 though, it's 0 plus 3 radians. So let's make this, it's easier if it's in degrees, I think. But I'll just make this a decimal. So 3 radians, and my y value is 3. My second point is going to be 3 pi over 4 plus 3 radians is 5.35 radians. So 3, 4, 5, a little more, and my value is 1. My next point then is back to 3, and then 3 pi over 2 plus 3 is 7.7, and I'm back to 3. And then I go 9 pi over 4 plus 3 is 10.1 about, and I'm back to 5. 8, 9, 10, back to 5, or to 5, and then I'm going to come back to 3 somewhere, well, 3 pi plus 3. 12.42. It's 10, 11, 12, a little more, back to 3. So it's going to be shifted right. I'm going to have a period that was less than what I started with. It would be easier if I actually graphed what the original sign looked like up here. But for me, it's just a process of going through each one of those coordinate points and figuring out what changes with that transformation. And there's a video in that section. It's either that section or the tangent section that I think it's James Souza that goes through the process of how each coordinate changes with this particular transformation. Not this one, but with a transformation of the period change, the phase shift, and then your increase or decrease on the y-axis, and then at the flip over the x-axis, and what the amplitude does to the graph. Okay, so I just try and methodically, it's not like I can look at a graph or look at an equation and just visualize what it looks like in my mind. I have to go through what the original points are and figure out what the new points are based on that transformation. Okay, if I'm given a graph, I do a little better going backwards from the graph to the equation, because I can kind of look at it and say, and we were working on that earlier, where you can say, well, is it sine or cosine that's going to be the best match for this one, and try and pick the trig function that's going to cause the least amount of transformation. If you can get a sine graph and you can see that it starts at 0, 0, and you're just going to have an amplitude change and maybe a period change, that's a lot easier than trying to make it a cosine graph and then having to add in a phase shift. Because that's really all the cosine is a sine graph with a phase shift. Okay. Do you guys have a problem in 2.4 that you want me to do? Are you still working on web work? Are yours, where are you having struggles going from the graph to the equation?
Yeah.
Okay. So let's pull up a web work problem. And I'm going to have to go into trig. Let me just go into one of mine here, 2.4. Which problem? Okay, so it may not be exactly what yours is, but I can talk you through how I would do this one. First off, I would look at the period, how long from crest to crest. And it looks to me like it goes 1, 2, 3, we'll do it that way, okay? 1, 2, 3, 4, 5, 6 units from crest to crest. Okay, so then I would know 2 pi over 6, which is pi over 3, is what would be right here, pi over 3. Now, I want to figure out whether I want to do sine or cosine. I would probably do sine. Do you see how halfway through the graph here, it crosses the y-axis? So if I use sine, I'm going to have to make it negative because it flips over and it starts down instead of up. But if I use sine, I don't have a phase shift, which is nice. So I don't have to count how many units it moved off of the y-axis. Okay, so it's going to be negative sine. I'm going to put in parentheses pi over 3. There's no phase shift, so it's just going to be x. It's not. It is shifted down though. It's shifted down 1 unit. So then it would be parentheses after the x and then minus 1. Then I would check and see if I have an amplitude. So from this point, which is where normally it would be 0, 0. Instead of going just 1 unit, it goes 1, 2, 3 units. So it's got an amplitude of 3. So it would be negative 3 sine pi over 3x minus 1.
Wait, how did you get the amplitude?
I figured out where the midpoint, the midline is for this graph. And you see how if it were just sine, it would just go to 1, 1, 1, negative 1, 1, negative 1. But it goes up 3 units. So that means it was stretched by a factor of 3. That help?